All right, let's go ahead and review test 4 or 362. Excuse me. The first four problems are graph the inequality on a number line, then write the solution in interval notation. Let me go ahead and zoom into the first problem here. And let me zoom in further so you can see better. All right, what I'm going to do is I'm going to first draw my number line. This is positive infinity. This is negative infinity. I'm going to have a 0. I'm going to have a -2, -4, -6, 2, 4, and 6. Now they're asking me to shade the region less than or equal to -2. So I'm going to go ahead and shade the region less than or equal to -2. Because it is less than or equal to, I am going to have brackets. Let's refresh this one. Greater than or less than, parentheses, greater than or equal to, less than or equal to, brackets. They're asking us to write the solution in interval notation. So I start from negative, you start from negative infinity and you stop at -2. So negative infinity, parentheses, comma, -2, brackets. Remember, infinity, positive or negative, is always going to be parentheses. Now moving on to the next problem. X less than 3. I am going to go ahead and draw my number line. Infinity, negative infinity, 0, and 3. They asked me to shade the region less than 3. So I'm going to shade towards the left hand side. Because it is less than, I am going to have a parentheses. Interval notation, you start from negative infinity and stop at 3. So it's going to be negative infinity to 3, parentheses. Moving on to the next problem. X greater than -4. And again, I'm going to go ahead and draw my number line. Negative infinity, positive infinity, and I'm going to have a 0 here and a -4 here. I'm graphing greater than -4, shading, so I'm going to shade towards the right hand side. Because it is greater than or equal to, I will have a bracket. So I'm starting from -4 going all the way up to infinity. Infinity, no matter what, is parentheses. -4 is closed in this case. Moving on to the next problem. In this problem, you have a couple of steps to do extra than the previous ones. So I cannot work because I have these parentheses. So what I'm going to do, there's so many ways of doing this problem. You can divide everything with 5 or you can distribute it. But what I am going to do is I'm going to go ahead and distribute it so you can see what's going on here. So 10 times 2 is 20x. Now 10 times, oops, let me change my cursor. 10 times -1 is -10, greater than or equal to 5 times 3 is 15x, and 5 times -4 is -20. My x looks like an n here because of my cursor. And now what I'm going to do is I'm going to bring all the x's to one side. So I subtract 15x on both sides. What do I end up with? 20 minus 15 is 5x. And now I add 10 on both sides. What do I get? -20 plus 10 is -10. I divide with 5 on both sides. I end up with x less than or equal to -2. So I'm going to go ahead and graph that on the number line here. I'm just going to scroll it over. This would be my number line. Always negative infinity, positive infinity first. A 0, a -2. Less than -2 is towards your left. Because it is less than or equal to, I will have a bracket. So my answer is going to be negative infinity to negative 2 closed parentheses. The next problem here is, let me go ahead and scroll it up. Solve the inequality, write the solution in interval notation. The inequality is negative 5x is less than negative 20. So what I'm going to do is I'm going to go ahead and make a partition here so I can work both of them and you can see what is going on simultaneously. Excuse me. Negative 5x is less than negative 20. I need to get x by itself, so dividing both sides with negative 5, dividing both sides with negative 5. Negative, negative cancel each other. Negative 20 over negative 5 is positive 4. And x. Remember, anytime, every time you multiply or divide with a negative number, your inequality flips. So this is going to be my final answer for this side. Now let me go ahead and check on the other side. I subtract 5 from both sides of the inequality. So what do I get? X greater than 3. So I am trying to look for a number greater than 4 and greater than 3. So let me go ahead and graph this so you can see. When I say and, it has to be the intersection of both. That number I picked has to satisfy both the conditions. That number has to satisfy x greater than negative 4 as well as x greater than 3. Sorry, x greater than positive 4 and x greater than 3. So let me go ahead and graph that. I'm going to have it on the number line. Let's say this is 4 and this is 3. I'm going to use two different colors here. I'm going to first graph x greater than 4. Greater than 4 is towards infinity. I will be graphing it this way and open parentheses. I'm going to use another color. Greater than 3 is going to be in red and going all the way to infinity and open parentheses. Now the question is, what part of your graph do you see that is common for both of them? So when I'm looking at the graph, I'm trying to find a number that is greater than 3 and greater than 4. That means my shaded region is from 4 to infinity. If I pick a number that is greater than 4, it's automatically going to be greater than 3. But if I pick a number greater than 3, which is 3.5, that might not be greater than 4. So my final answer here is, or the easiest way to do is, every time you see a and, you're going to graph both your graphs on the same one and see what part of your graph is common to both of them. In this case, it is from 4 to infinity. All right, moving on to the next problem. I'm trying to solve the inequality for 2t minus 4 less than or equal to 8. So whatever you do in the middle, you should be doing the same thing on either sides of your inequality. So what I'm going to do is I'm going to add 4 first. When you add 4 on this side, you add 4 on this side, and you add 4 on this side. Positive 4, negative 4 cancel each other. And 4 and 4 is 8, less than or equal to 2t less than or equal to 12. Now, divide by 2. Remember, whatever you do in the middle has to be done on either sides of your inequality. 2 and 2 cancel. T less than or equal to 6. T greater than or equal to 4. When I'm graphing the inequality, 4 and 6. So I'm picking a number that is less than 6 and greater than 4. So that numbers, the range of numbers or the set of numbers have to be in between 4 and 6. Okay, so T has to be in between 4 and 6. So you're picking a number that is greater than 4 and less than or equal to 6. So the numbers that are greater than 4, greater than or equal to 4, less than or equal to 6 are the numbers that are in between 4 and 6. Now moving on to the next problem. This one looks slightly tilted. Let me move it. There you go. Okay, or. So what I'm going to do is I'm going to draw a line. That's the way I like to do it, so I know I'm working on both of them and not forgetting any one of them. I add 4. I add 4. So I have 6x less than or equal to 18. Remember, your aim is always to get x by itself. So that's going to be your aim all the time. You're going to divide by 6, divide by 6. Oops, did I put less than or equal to here? Okay, let me just take it off. It is simply less than. So 6 and 6 cancel. X is less than 3. Moving on to the next inequality and trying to get x by itself. So divide by negative 2. Divide by negative 2. Negative 2 gives me a x. Negative 4 over negative 2 gives me a positive 7. Remember, every time you multiply or divide with a negative number, your inequality flips. So less than now becomes greater than. So let me go ahead and graph this. It's a or. So I can pick a number that is greater than 7, or I can pick a number that is less than 3. So let me go ahead and graph that. So 3 and 7. Infinity, negative infinity. Graphing x less than 3. Less than 3 is towards the left hand side, and it is parentheses. Greater than 7, and the right hand side. So looking at this, I can pick a number from this set or from this set. If it's a and, it has to satisfy both the conditions. If it's a or, it doesn't have to satisfy both the condition. Or is like a union, and is like intersection. So your final answer is going to be negative infinity to 3 or 7 to infinity. Both of them are brackets here. In my cursor, it looks like it's both of them are parentheses here. My cursor, it looks like it's a brackets, but both of them are parentheses. Moving on to the next problem. Absolute value equations. Most of the students make a mistake when you're working with absolute values is they solve for only one value. They forget that absolute value always has two answers. So what I do in absolute value is I simply draw a line reminding myself that I'm going to have two different equations to solve. In absolute values, we know that if absolute value of x is equal to a, that means x is positive a and x is negative a. So having known that, I'm going to go ahead and work this out. The first step in absolute value is to make sure the absolute value is by itself. What I mean by that is everything has to be inside the absolute values. In this case, it is, so I'm going to go ahead and write 2x minus 3 is 5. And I have another case, 2x minus 3, that is equal to negative 5. If you go ahead and draw this line and do it one positive, one negative, there's no way you're going to forget. Add 3, 2x is 8, divide by 2, your x is 4. Add 3, 2x is negative 2, divide by 2, x is negative 1. So your answers are x is equal to 4 or x is equal to negative 1. Moving on to the next problem. Absolute value of x minus 5 plus 4 is 7. In this case, the absolute value is not by itself. I have an extra 4 here, which I don't need. So what I'm going to do is I'm going to subtract 4 on both sides. First step. So I have absolute value of x minus 5 is equal to 3. Once I have this, I'm going to go ahead and draw my line, reminding myself that I will have two cases, which is x minus 5 is equal to positive 3 and x minus 5 is equal to negative 3. I add 5, add 5. X is equal to 8. I add 5, add 5. I get x is equal to 2. So your answer is x is equal to 8 or x is equal to 2. You guys have to excuse me for the x's here. My cursor for some reason is not working and my x's kind of look like they are r's and n's, but they are x's. Alright, moving on to the next problem. It looks slightly tilted here. Absolute value of x minus 3 plus 8 is equal to 9. So, and again, 8 here is extra. So I'm going to subtract 8 on both sides. And when I subtract 8, I have absolute value of x minus 3 is equal to 1. I'm going to draw a line reminding myself I have two cases here. X minus 3 is 1 and x minus 3 is negative 1. I add 3, add 3. I get x is equal to 4. Add 3, add 3. I get x is equal to 2. I have two cases here, x is equal to 4 and x is equal to 2. Moving on to the next problem. Why does this look tilted to me? Alright, I'm going to expand this so we can see it better. Absolute value of 9x minus 9x minus 9 is equal to absolute value of 2x plus 19. I always draw a line, so I know I'll have two cases. First case, both of them are positive. 9x minus 9 is equal to 2x plus 19. Second case, one is positive and the other one is negative. So negative of 2x plus 19. I am going to go ahead and add 9, add 9. Remember, you have to get x by itself. 9x is equal to 2x plus 28. Subtract 2x, subtract 2x. I get 7x is equal to 28. X is equal to 4, dividing both sides with 7. I have 9x minus 9 is equal to negative 2x minus 19. Add 9, add 9. I have 9x is equal to negative 2x minus 10. Add 2x, add 2x. I have 11x is equal to negative 10. Divide by 11, divide by 11. I have x is equal to negative 10 over 11. Moving on to the next problem, and again I need to make sure absolute value is by itself, so I subtract 1, subtract 1, and absolute value of 2x plus 1 is less than 7. Now let's go ahead and see what they want us to do. This is an inequality and I am solving it. So absolute value of x less than c, the solution would be x is in between positive c and negative c. So I'm going to go ahead and use the formula here. So my 2x plus 1 is in between positive 7 and negative 7. Subtract 1, subtract 1, subtract 1. Remember, whatever you do in the center has to be done on both sides of the inequality. Negative 8 and less than 2x less than 6. Divide by 2, divide by 2, divide by 2. What do I end up with? Let me scroll this over. I end up with, I'm going to change the color so you can see. I end up with negative 4 less than x less than 3. So I'm trying to write this in interval notation. So your x has to be in between negative 4 and 3. I would suggest the best thing to do is graph it out. Negative 4 and 3. So x has to be less than 3. X has to be less than 3. At the same time has to be greater than 4. That can happen if and only if x is in between negative 4 and 3. Both of them are parentheses. Moving on to the next problem. First step first, absolute value has to be by itself. You subtract 5, you subtract 5. Change the color here. 5 and 5 cancel. Absolute value of 6x minus 3 is greater than 21. Now what I would do is I would try to do the same thing like the previous one. This is just my way of doing it. But when you graph it, you got to be very careful. So this is 6x minus 3 greater than 21. I put the same sign, greater than negative 21. I add 3, add 3, add 3. I get 6x greater than 24 or negative 18. Negative 18. And now, remember x has to be by itself. Divide by 6, divide by 6, divide by 6. So I have x greater than 4 or x is less than negative 3. But the way you would read it is, you would read it as two inequalities. One, x greater than 4 or x less than negative 3. When you graph it, I'm going to scroll this over so you can see the graph. I'm going to minimize it. I'm going to go ahead and graph this here. I have 4 and I have negative 3. Negative infinity and positive infinity. So x has to be greater than 4. I'm going to graph the first one. X has to be greater than 4. That is going to be all the way to the right hand side, greater than, so it's a parenthesis. I'm going to graph the second one, x less than negative 3. X less than negative 3 is towards the left hand side, and it is also a parenthesis. So how would I write my interval notation? Negative infinity to negative 3 or 4 to infinity. So I just write down the same thing with the inequality signs, and you're going to go ahead and graph it and write your interval notation. Determine if the ordered pair for negative 3 is a solution to x minus y greater than 5. You're going to go ahead and show all your work. So I would write down, I always keep forgetting to change my cursor, x minus y greater than 5. My x is 4, so it's 4. My y is negative 3 greater than 5. Let me check if this inequality is right. So 4, negative off, negative makes it a positive. 4 plus 3 greater than 5. 4 plus 3 is 7, greater than 5 is true. So 4 negative 3 is a solution. It is a solution. All right, moving on to the next one. Graph the inequality x plus 3y less than or equal to negative 3. When I'm graphing these inequalities, what I would do is I would go ahead and solve for y first. That's the easiest way to work it out. So I'm going to go ahead and solve for y. X plus 3y less than or equal to -3. I subtract x from both sides, so I have 3y less than or equal to -x minus 3. I divide by 3, divide by 3, divide by 3. I have y less than or equal to -1/3 x minus 1. This 1/3, I write it as 1/3 x. Now my slope is 1/3 and my y-intercept, let me rewrite this one, and my y-intercept here is -1. So when I'm graphing it, let me see how much I can expand it. When I'm graphing it, I always start with my y-intercept. In this case was -1, and my slope is -1/3. Remember, slope is rise over run, so I would move 1 unit down and 3 units to the right. So my second point is this. And then I'm going to start the same thing, 1 unit down, 3 units right. That's my another point. And when I'm moving upward, it would be 1 unit up and 3 units to the left. That's my next point. 1 unit up, 3 units to the left, second point. So when I go ahead and graph this line would be something like this. I hope I can get it straight. I did not. Okay. So that is going to be my line here. So let me just erase these extra ones here so it doesn't bother us. Okay. And now they're asking us to graph the inequality. They're asking us to graph the inequality here. So let's go ahead and see what the inequality is. They're asking us to graph or shade the region where y is less than. So what we need to do here is you're going to take a test point that is not on the line. So I would take a test point. You could take any point, but you cannot take the points that are on the line. So I'm going to take a point. The easiest point here is 0, 0. So what I'm going to do is I'm going to take my test point and plug it in to check if that is a solution. If that is true, I'm going to shade the area the test point lies. If that is false, I'm going to shade the opposite area. Let's go ahead and test. Test point is 0, 0. I'm going to plug in. This is my x, this is my y. I'm going to plug this into this inequality, or you can plug it into this inequality. Let's go ahead and plug it in there. So when I plug this in, 0 plus 3 times 0 is less than or equal to -3. 0 plus 0 is 0. 0 less than or equal to -3. That's not true. 0 is not less than -3. So I cannot shade the region the test point lies. I cannot shade this region. This region cannot be shaded. I need to shade the opposite region. So let me go ahead and see if I can shade that. I'm going to use a blue color. So because I cannot shade the region the test point is, I have to shade the other region. I'm going to use a blue color here. So I have to shade this region. So that is telling me that all these points that lie under this line satisfy the condition y is less than or equal to -1/3. So let me repeat myself here. What you do is you take a test point. You take a test point here. I took a test point 0, 0, and I plug the test point in there. And if it satisfies, you shade the region your test point is. If it does not satisfy, you shade the region your test point does not lie in. So technically you're shading the region that's opposite of your test point. So let me go ahead and clear this. All right. Moving on to the next problem. Y is less than or equal to 2x minus 3. Y is less than or equal to x plus 4. they're asking us to graph the solution of this linear inequality. First step first, we're going to go ahead and graph the inequality here. Okay, I'm going to graph the first problem, 2x minus 3. So my y-intercept is -3 and my slope is 2. So when I say the slope is 2, I'm going to go 2 up and 1 right. 2 up and 1 right. 2 up and 1 right. So technically my line would be something like this. I'm going to see if I can make it a straight line. Let me zoom in here. I have to zoom in because I cannot, the stylus pen doesn't work that well. So 2 up, 1 right would be this point. 2 up, 1 right would be this point. 2 up, 1 right would be this point. Okay. And 2 down, 1, 5 and 1, this point. Oh, I can't draw straight lines. So that's how my line's going to look. Now I'm going to go ahead and graph the second line, x plus 4. So I'm going to start with 4 as my y-intercept. I have to zoom this, and the slope is 1 over 1. So I'm going to use another point. 1 and 1, 1 and 1, 1 and 1, 1 and 1. 1 up, 1 right. So I'm going to stop this, zoom it in, and graph it. So now you're going to go ahead and shade the region. So for the first one, y is less than 2x minus 3. So what you do is you take a test point here. My test point would be 0, 0. So I'm going to take a test point 0, 0. So I'm going to plug 0 less than 2 times 0 minus 3. 0 is less than -3. That's a false statement. So because you're taking a 0, 0 here, you don't shade above, you're going to shade below. So you're going to shade somewhere here. All right? Okay. Now, for the next one, I'm going to take a red color here. I'm going to take the points 0, 0 and test this line. Oh, the width is too big. So when I take 0, 0, it's going to be 0, 0 less than 0 plus 4. 0 is less than 4. That is true. So you're going to shade the region that your test point lies in. Your test point is this for this line. So you're going to shade the region that your test point is in. So when you shade it, right? So now your solution is going to be all that area where you have both red and blue. So your solution is going to be this area. So when I'm going to shade it, I'm going to shade it in the opposite direction so you can see what I'm talking about. And I'm going to use a different color here so you can see. I'm going to use a yellow. So your solution is going to be everything from here. All this is going to be your solution. Let me go ahead and expand this so I can show you exactly what the solution. So all the portion where your red and blue intersects would be your solution, the red and blue. So all this part would be your solution set. My cursor sometimes doesn't work with me, so you have to bear with that. So all this is going to be a solution set. So intersection of both red and blue is your solution. Moving on to next set of problems here. I'm going to change my color back to black and simplify the radical expression. The best way to simplify is to change it into exponential. Remember, if you don't see an index, the index is, oops, big width. The index is 2. If you don't see an index, the index is 2. I'm going to change this to exponential here. So this would simply be y to the power 10 over 2. which is going to be y to the power 5. Moving on to the next problem. There's so many ways of doing this. You can change this into an exponential like we did before, or what I'm going to do is I'm going to work with numbers. I'm first going to find the cube root of 64. That is, the number that you multiply by itself 3 times give you 64, and that would be 4. So 4 times 4 times 4 is 64. So cube root of 64 is 4. Now when coming to variables, what I would do here is, let me go ahead and erase this number. What I would do is I simply divide the power with the index. So 9 divided by 3 is 3. So let me repeat. You first find the cube root of 64 and then you will divide your power with your index. Alright, that's another way of working it out. Moving on to the next problem. I am trying to find the square root of 36. Square root of 36 is 6, and then do not forget the negative sign. You bring it back, negative. Now cube root of negative 27. That is, you pick a number that you multiply by itself 3 times and gives you negative 27, which is negative 3 times negative 3 times negative 3. So the cube root of negative 27 is negative 3. Moving on to the next problem. Fourth root of negative 9. So I cannot find a perfect fourth root of negative 9. So I'm simply going to change this to exponential negative 9 to the power 1/4. Alright, use radical notation to write this expression, and simplify if possible. We know that square root is nothing but to the power half. So here we have 16 to the power half, which is nothing but square root of 16, which is 4. Moving on to the next problem. 1/3 is nothing but cube root. So negative 27 cube root is, you find a number that you multiply by itself 3 times, gives you negative 27, which is negative 3. Moving on to the next problem. Write with positive exponents. Remember, if you have a negative on the top, if your exponent is negative on the top, it simply becomes positive in the bottom. If it is negative, hold on, let me just erase this one. If it is negative in the bottom, simply becomes positive on the top. So in this case, when I look at it, I see that the exponent is negative in the denominator. So I'm simply going to move it to the top and make it a positive. Okay. X to the power m root of n is written as, in exponential notation, m over n. When we look at this one, m is nothing but 6. N is nothing but 24. So I have my m as 6 and n as 24. When I rewrite it, x to the power m over n. I can simplify this to 1/4. So this is simply x to the power 1/4. If you want to rewrite it back into radical, you're going to use the same formula. So it's going to be x 4th root. Either way, anyway. Good luck.